second Saturday of the month of August 2026. You are welcome to Oxygen FM 96.9, and the program is still School on Here Physics as usual, and I'm here, your regular host, Kenny Badmus. I want to use this opportunity once again to say a good day to all our distinguished listeners, students, parents, our teachers at home, and all lovers of knowledge. Whether you are in second and students alike, mostly, more importantly, our students who are our regular listeners and participants on this program. I want to say a big thank you and good morning to every one of you. Whether you are a secondary student, a university undergraduate teacher, artisan, a driver, engineer, sports person, simply someone who enjoys learning, definitely today's lesson is designed for all of us. So physics is not confined to classroom. It explains the world around us every single day. So today, the topic of today is still on efficiency of machine. Efficiency of machine. Efficiency of machine. And majorly classifications of machines. Classifications of machines. So I want to say on behalf of the management of this station, I want to say a big thank you once again and to welcome everybody on board. Yeah, straight to work. So before I start today's on my first segment is the Wisdom Council, but I want to go back to say a word of appreciation to the management and the production crew of Oxygen FM 96.9, situated at the Knowledge Hub 121-122 Wafami Awolowo Way, Okeado, Ibadan. I welcome you all to today, which is another exciting and transformative edition on School of on Here Physics on Oxygen FM 96.9. Thank you. So the first segment is the Wisdom Capsule. Today's Wisdom Capsule comes from the great physicist, great physicist who is known as Sir Isaac Newton. Sir Isaac Newton. I think last week we brought Sir Joel. We brought the Wisdom Capsule from Joel last week. Today, our great physicist, our symbol of learning today is Sir Isaac Newton, who lived between 1642 and 1729. He said, and I quote, that if I have seen Father, it is by standing on the shoulders of giants. I quote again, that if I have seen Father, it is by standing on the shoulders of giants. Let me repeat, that he says, and I quote, that if I have seen Father, it is by standing on the shoulders of giants. So this is a timeless statement that reminds us that learning never ends, and you tap opportunities of those who know. So every generation builds upon the knowledge of those before. So that's an indication that you do not invent anything new, but you take opportunities from those who have done something worthy of note in the past. So every generation builds upon the knowledge of those before it. So continue reading, asking questions, experimenting, and improving yourselves. So, to the topic of today, efficiency of machine with focus on classification of machines. Machines can be classified in several ways. depending on their function and source of power. Last week, we started with classification, and we were only able to continue with efficiency of machines, and we were able to start with classifications with focus on lever system. So machines can be classified in several ways depending on their function and source of power. The most common classifications are for the simple machines that we are all used to. So the simple machines is a basic mechanical device that makes work easier by changing the direction and magnitude of force. If you remember that what machine does is that it changes direction and increases the magnitude of a force. So that is for the simple machine. So those simple machines are the ones that we want to deal with. We want to treat them one by one, like we did last week with lever. So simple machines include lever, pulley, wheel and axle, inclined planes, wedge, and screw. Simple machines include lever, pulley, wheel and axle, inclined planes, wedge, and screw. Then we have the complex or compound machines. These machines are combinations of two or more simple machines. The complex or compound machines are machines that are made by combining or the combination of two or more simple machines. Complex machines are a combination of two or more simple machines. Where we have an example as bicycle, sewing machines, cranes, cars, aeroplanes too, etc. Now, according to the source of power, and according to function, that is how classification of machines how machines are classified. So according to the source of power, we have the manual machines. The manual machines are powered by human efforts. According to the source of power, we have the manual machines, which are powered by human efforts. We have the animal powered machines like the camels, bulls, and the likes. So that is classification according to source of power. Also, we have the electrical machines. It is true also according to the source of power. It is classified according to source of power. We have the hydraulic machines, which is powered by liquid. We have the pneumatic machines, which is powered by compressed air, oxygen or compressed air. So we have the internal combustion engine. We have the machines powered by fuel. So once again, I say machines are classified according to source of power, where we have the manual machines powered by human efforts, animal machines powered by animals, electrical machines, hydraulic machines that's powered by liquid, pneumatic machines that's powered by compressed air combustion engine, and machines that are equally powered by fuel. Secondly, we have classification according to their functions. According to their function, we have the power generating machines, like generators and the engines that we see outside. Yeah, they are the least that we can see. When you talk about power generating machines, let's think about generators that are being used in our generating stations, like the Kanji Dam, for example. So these are specialized power generating machines. You cannot see them on the street. They are not even available. They are specially designed and ordered from specialized manufacturers across the globe. So we also have, according to the function, we have power transmitting machines. The power transmitting machines, we can see them in our automobiles. The gear system, the belts, and the chains. So for power transmitting machines, we have the gear system, the belts, the chains, and the likes. We have working machines too. Working machines for works. Working machines. Under that, we have the lathe machines. These are form work. It's not ordinary walking. Walking, W-A-L-K-I-N-G. No, but working, W-O-R-K-I-N-G. It is form work. It should have been better put as form work machines. Where we have, it's mostly mechanical instrumentations, workshops. So where we have the lathe machines, the drilling machines, the pumps, etc. So they are used to form, to make designs. So in basic engineering and technology, the broadest classification is simple machines. So our focus today is basically on simple machines. So under the simple machines, we have the lever system, we have the pulley, we have the wedge, the inclined planes, we have the wheel and axle, we have the screw. Now, let's start with, we started last week with lever. So lever, like we did, as the lever has a principle that works according to the principle of moments, which is clockwise moment and anti-clockwise moment. The clockwise moment is equal to anti-clockwise moment mathematically. So we have the effort times effort arm is equal to load times load arm. So the classes, this is just a review. That's because we did it extensively last week. So we have the classes, the first class, second class, and the third class. The first class, we know that the arrangement is usually have the fulcrum between efforts and load. So the pivot or the fulcrum is between effort and load. The examples are seesaw, scissors, crowbars, pliers. The second class is the wheelbarrow, the bottle opener, and the nut crackers. So the efforts, this time the load stands in between the fulcrum and the effort. So the load stands in between the fulcrum or the pivot and the effort. So that at the third class and the second class, the mechanical advantage is usually greater than 1. So the MA, which is the mechanical advantage, is usually greater than 1. The third class, we have the efforts this time standing in between the fulcrum and the load. At the third class, we have the efforts standing in between the fulcrum or pivot and the load. So woman, forearms, fishing rod, tweezers, and broom are examples. So a third class has a clear advantage because it increases speed and distance rather than force. So the speed and the distance is of advantage because we don't have to use much of force. So and we did extensively with its efficiency, which is equally the mechanical advantage over velocity ratio times 100%. So today we're starting with the pulley. Types of pulley. The pulley system is a simple machine that consists of a grooved wheel with a rope, belt or chain running over it. So a pulley is a simple machine consisting of a grooved wheel with a rope, belt or chain running over it. It is used to lift or move heavy loads with less effort by changing direction or magnitude of the applied force. So a pulley is a simple machine consisting of a grooved wheel with a rope, belt or chain running over it. It is used to lift or move heavy loads with less effort by changing the direction and magnitude of the applied force. So we have the types of pulley. In the types of pulley system, we have the fixed pulley, we have the movable, we have the compound pulley, which is the block and tackle. And let me start off with the fixed pulley. The fixed pulley is a pulley that is attached to a fixed support. So a fixed pulley is a pulley that is attached to a fixed support. Changes in the direction of the applied force, but does not reduce the effort required. It changes the direction of the applied force, but does not reduce the effort required. So mechanical advantage this time is 1. So like example is drawing water from the well. So the simple machine that we use to draw water from a well, that's an example, a clear example of a fixed pulley. We have the movable pulley. So under movable pulley, we have attached, a movable pulley is attached directly to the load and moves it. So a movable pulley is attached directly to the load and moves it. So it reduces the effort needed. However, remember that in fixed pulley, it does not reduce effort. So but this one reduces effort needed to lift the load. So mechanical advantage this time is equal to 2. That's an ideal case. So MA, which is a mechanical advantage, equals to 2 in an ideal case. So example is some lifting hoists. Lifting hoist, which is HOIST, like flag hoist. If you look, students at home, I want to remind you, when you watch your films, remember you watch when you watch adventure films, where adventure and exploration films, where you see films being shown on the sea, inside the ship. So you see, there are times they want to hoist the flag so that the oncoming ship will know that this ship belongs to us. This ship is part of our expedition, or this ship belongs to my country. So that's the example. So mechanical advantage, like I said, MA is equal to 2 in our case. So compound pulley this time is a block and tackle. It's called the block and tackle. It's a combination of fixed and movable pulleys. Compound pulley is a combination of fixed and movable pulley. It greatly reduces the effort to lift heavy loads. So remember, the first one, which is the fixed pulley, does not reduce effort. The second, movable pulley, reduces effort. But the compound one reduces effort greatly. So it greatly reduces effort required to lift heavy loads. It is used in construction sites, cranes, and shipyards. So advantages of a pulley: it makes lifting heavy loads easier. So we've been saying this over and over. It makes lifting heavy loads easier. It can change the direction of the applied force. It can change the direction of the applied force. It saves time and energy when lifting loads. It saves time and energy when lifting loads. So also, it can provide mechanical advantage depending on the arrangement. So advantages, like I said, it makes lifting heavy loads easier. It can change the direction of the applied force. It saves the time and energy when lifting loads. It can provide mechanical advantage, MA, depending on the arrangement. Disadvantages are like, disadvantages is that friction reduces efficiency. So friction reduces efficiency. And mostly our focus is on the efficiency. We want to have increased efficiency of machines. So this pulley, friction here reduces efficiency. So multiple pulley require more ropes and space. That's number 2 disadvantage. Multiple pulley require more rope and space. So the rope and cable can tear apart or wear off anytime. So thereby creating emergencies. So those are the 3 disadvantages. The overall applications of pulley. In overall, applications of pulley are in cranes, elevators, flagpoles, wells, construction, lifting equipment, and window blinds. Overall applications of pulley are in cranes, elevators, flagpoles, wells, construction, lifting equipment, and window blinds. For the formula, the mechanical advantage is still load over effort. The load divided by effort is the mechanical advantage. But the velocity ratio is the distance moved by effort divided by distance moved by load. Please note that velocity ratio is distance moved by effort divided by distance moved by load. There's no change according to what we did last week, which about level system. So that distance velocity ratio is still distance moved by effort divided by distance moved by load. So where the efficiency remains the same, that's mechanical advantage divided by velocity ratio times 100. Let's have a mathematical example. You will have a pulley that lifts a load of 200 Newton with an effort of 100 Newton. A pulley lifts a load. Note that a load is of 200 Newton is being lifted with an effort of 100 Newton. Simple as ABC, the mechanical advantage is load over effort, which is 200 over 100, gives us 2. So, however, or in addition, if the velocity ratio is 2.5, then what is the efficiency? If the velocity ratio is 2.5, what is the efficiency? We know that efficiency is mechanical advantage divided by velocity ratio times 100. So, having gotten our mechanical advantage as 2, efficiency now becomes mechanical advantage divided by velocity ratio times 100, which is 2 divided by 2.5 times 100. That gives us 80%. That gives us 80%. So, welcome back. The next classification is the wheel and axle. On the next classification, we have the wheel and axle. A wheel and axle is a simple machine, like we said earlier. A wheel and axle is a simple machine made up of large wheel rigidly attached to a smaller shaft. A wheel and axle is a simple machine made up of a large wheel rigidly attached to a smaller shaft, the axle. So when the wheel is turned, the axle also turns. When the wheel is turned, the axle turns, making it easier to move or lift the load by multiplying effort. The example can be seen in milling. Milling machines like domestic pepper grinders. You can see at the back, you can see the head of the of the milling machine, the bowl, the metallic bowl. So you can see it at the back of it. You see the wheel, and down by attached to that wheel is also the axle too. So, and it is rigidly attached to the smaller unit of the shafts rather. So by the side of the electric motor, you see the axle, but attached to the wheel rigidly is the smaller shaft. That is, the shaft is the one that grinds the pepper. So when the wheel is turned, the axle turns, making it easier to move or lift loads by multiplying force. So the principle behind wheel and axle work by increasing the turning effect. The principle work of wheel and axle works by increasing the turning effect. That's what they call the torque, which is in Newton meters. So the wheel and axle works by increasing the turning effect, that is the torque. So applying effort to the larger wheel produces a greater force at the smaller axle. So applying effort to the larger wheel produces a greater force at the smaller axle. So the parts associated are wheels, shafts, axle. So the wheel is the larger circular parts where effort is applied. So the wheel is the larger circular part where effort is applied. The axle is the smaller shaft attached to the wheel that rotates it. So the axle is the smaller shaft attached to the wheel that rotates it. Where now the mechanical advantage is load over effort. Mechanical advantage is load over divided by effort. So in an ideal wheel and axle, the velocity ratio is equal to radius of the wheel divided by radius of the axle. So in an ideal wheel and axle, the velocity ratio is radius of the wheel divided by radius of the axle, and efficiency remains the same as mechanical advantage divided by velocity ratio times 100. So advantages and disadvantages and applications with mathematical example. Now the advantages, are run over that to save our time. So the advantages are that it reduces the effort needed to move or lift heavy loads. So advantages of the wheel and axle is that it reduces effort needed to move or lift heavy loads. It also increases the turning torque, that is the turning force rather. The torque is increased. So it makes also, number 3, it makes work faster and easier. And number 4 is that it's simple and durable. So disadvantages are that 1, friction reduces efficiency, largely, like we said. So disadvantage is that friction reduces efficiency. Large wheels require more space. That's number 2. And 3, it can be difficult to operate it if it's overloaded. It can be difficult to operate it if it is overloaded. That's the disadvantage. That's the number 3 disadvantage. Now the application. The application goes to the steering wheel of a car. So the wheel and axle has applications in steering wheel of a car, the doorknob, the water well windlass, the screwdriver, bicycle wheel, hand operated winch. Applications are steering wheel of a car, doorknobs, water well windlass, screwdriver, bicycle wheel, hand operated winch. etc. So mathematical example this time. If there is a wheel and axle that lifts a load of 300 Newton with an effort of 100 Newton, the mechanical advantage is the load divided by effort. So that gives us 300 divided by 100. The MA now, mechanical advantage is 3. So by extension, if the wheel radius is 30 centimeters and the axle radius is 10 centimeters, what is the velocity ratio this time? Remember that velocity ratio is the radius of the wheel divided by radius of the axle, which is now 30 divided by 10. So the velocity ratio is 30 centimeters divided by 10 centimeters, which gives us 3. So the mechanical advantage and the velocity ratio are the same. They are 3, 3. So efficiency, greatly we can say is 100% in that case, because efficiency is MA over VR times 100. But however, in practice, there's nothing like that. It is just theoretical. So the key point is that a larger wheel compared to the axle means less effort is needed to move or lift the effort. When we have larger wheels compared to the axle, so it means that less effort is needed to move or lift the load. That's to say that as much as we can increase the wheel in proportion to the wheel to the axle, so we have less, so we use less effort. It will require, the wheel and axle will require less effort in this case. So let's have a break. So welcome back. Now we are on inclined planes. We've treated pulley, we've treated wheel and axle, and we're now on inclined planes. Inclined planes is a simple machine that consists of a sloping surface used to raise or lower a load with less effort. So an inclined plane is a simple machine that consists of a sloping surface used to raise or lower load with less effort. So acceleration here, because of the ramp, this can be viewed mathematically like a right angle triangle which has an hypotenuse. An hypotenuse, an opposite, and an adjacent. So that hypotenuse is treated like an inclined plane. So we have the acceleration being equal to g sine theta, where g is the acceleration due to gravity times sine theta. So, but a typical example can be seen in car wash environments. Typical example can also be seen at the auto mechanic workshops, automobile mechanic workshops. You can see them. So you can see ramps there. When you want to change engine oil, they can take the car to the ramp in auto mechanic workshop. Then they want to change certain things, certain components inside the engine. So the engine compartment needs to be lifted a bit up. That's why they enter ramp to give it a raise. That's indicating that the load is raised with less effort. So examples are in ramps, sloping road, staircases, loading platform, and slides. Examples of inclined planes are in ramp, sloping road, staircases, loading platform, and slides. We can also see this in our environment. Mostly the governments had made an enactment that allows governments and commercial buildings to construct ramps ramps that will make people with disabilities to have easy access. Unlike when a person living with disability wants to climb stairs, it's often difficult. It will be difficult for him, and it will be difficult for the person that supports the person with disability. But once there is a ramp, with less effort, you put him through the ramp on his wheelchair, and you get to the to your destination. So, how does the inclined plane works? So the inclined plane works. How does it work? Instead of lifting a heavy object vertically, the object is moved along the slope. That is basically simple. That instead of leaving objects, loads vertically up, so there is no need for that. It goes through the ramp, the slope. It goes through the slope. So a longer inclined plane requires less efforts. So longer inclined planes requires less efforts. Although the load travels a greater distance, because as long as the slope is, the distance increases. But as long as the inclined plane is, there is a less effort required. So mechanical advantage at the same time is still load over effort. The mechanical advantage is still load over effort. And in an ideal inclined planes, we say the word ideal because it's theoretical. It's not the practical. In practical terms, there are a bit of deviations. So for an ideal inclined plane, the velocity ratio is length of slope divided by vertical height. Please note that for an ideal inclined plane, the velocity ratio is the length of slope divided by vertical height, where the efficiency remains the same as MA divided by VR times 100. Let's have an example. A mathematical example goes thus: that a load of 600 Newton is moved up a ramp using an effort of 200 meters. Therefore, the mechanical advantage here is load over divided by effort, which is 600 divided by 200, which gives us 3. So velocity ratio now is the length of slope divided by vertical height. So we can now see that length of rope, the velocity ratio is the hypotenuse divided by opposites. If you draw an inclined plane like a right angle triangle, which has an hypotenuse, an opposite, and adjacent. So the velocity ratio as well can be hypotenuse divided by adjacent, depending on how you choose your angle. Now, the key point here is that inclined planes the inclined plane does not eliminate work. It only allows the load to be moved using force over a greater distance. So an inclined plane does not eliminate work. It allows the load to be moved using force over a greater distance. So next, when we come back, we go to the wedge. So welcome back again. So we have two left. We have the wedge and the screw. So what's a wedge? A wedge is also a simple machine that's made up of two inclined planes joined back to back. So a wedge is a simple machine that has two inclined planes joined together back to back. It is mainly used to cut. It's mainly used to cut, to split, to separate, or hold materials in place. So examples of wedge are knives, axes, chisels, nails, needle, door stops. Examples are knives, axes, chisels, nails, needles, door stops. How does a wedge work? A wedge works when a force is applied to the wide end of a wedge. When a force is applied to the wide end of the wedge, that's how it works. The wedge moves into the material and produces force sideways. So this allows it to cut or split the material. It allows the wedge, to cut or split the material into pieces. So uses of a wedge is in cutting, splitting, pressing, piercing. That's P-I-E-R-C-I-N-G. So in cutting, we have the knives and blades. In splitting, we have the axis that splits the wood. In piercing, we have the nails and needles. In holding, we have the doorstop that prevents door from moving. In shaping, we have chisels that remove materials. So we can see a few of these in carpentry workshops. So students, try and avail yourself of visits to these small neighboring workshops. The carpentry workshop, the auto mechanic workshop around you. Ask questions and see things. Even if you sit down or look from a distance, look at things they do. You see a number of things that we have talked here, that we are discussing here. You see them at work. So mechanical advantage is still load over effort. So for an ideal wedge, the mechanical advantage depends largely on its length and thickness. For an ideal wedge, the mechanical advantage depends largely on its length and thickness. Velocity ratio is the length of the wedge divided by the thickness of the wedge. So velocity ratio is the length of the wedge divided by thickness of the wedge. So examples: when we have a sharp knife that cuts more than a sharp knife now, it will cut easily than a blunt knife. So because of the cutting edge, because of the cutting edge, so it's sharper, it's thinner. So the thinner and the longer the wedges, the greater the mechanical advantage. So the thinner and longer the wedges, the greater the mechanical advantage. So when a sharp knife cuts more easily than the blunt one, that shows us that because of the thinner wedge, it makes it easier to cut. Then we have the screw. So in screw, a screw is also a simple machine. It consists of an inclined plane wrapped around a cylindrical surface. There's always a hold around a screw. If you have seen a screw before, mostly in houses we do have screws where we want to place our picture on the walls and a few things at home. So students, when you see a screw, so it's a simple machine. It consists of an inclined plane wrapped around a cylindrical surface. So that is the hold. So it is used to hold objects together, lift loads, and convert rotational motion into linear motion. So a screw is a simple machine that consists of an inclined plane wrapped around a cylindrical surface. It is used to hold objects together, lift loads, and convert rotational motion to linear motion. When you screw, you can see that it rotates. That's how it rotates. At the same time, it rotates and goes down, penetrates through linear motion. So examples of screws are in wood screw, bolt and nuts, screw jacks, vice, the jar lid, and the corkscrew. So the vice is the instrument used to shape or to get threading at on pipe surfaces. If you want to thread pipes, want to thread cylindrical objects, they use the vice. So how does a screw works? So the thread, it works in that the thread of a screw is essentially an inclined plane wrapped around a cylinder. So when the screw is rotated, the thread moves through the material or not, producing a forward or lifting motion. Now the uses. Screws are used in fastening. Screws are used in lifting. Screws are used in pressing. Screws are used in riveting. Screws are used in moving. So in fastening, joining pieces of wood or metals together, we can see that. Also in lifting, a screw jack can lift a vehicle. Pressing, it is used in screw presses and vices. So the mechanical advantage is same as load over effort. The mechanical advantage is the same as load over effort. So for an ideal screw, again, for an ideal screw, the velocity ratio is 2 pi r divided by pitch. So the velocity ratio is 2 pi r divided by radius. So radius is for the screw handle, while the pitch of the screw, or the distance between successive threads, so that is the velocity ratio. So the efficiency remains the same as MA over VR divided times 100. So we can have the caller studio lines opened where callers are expected to call in. 0704700 3969, 0704700 3969, 0704700 2969, 0704700 2969. So yeah, welcome back. Let's have a quick mathematical example where we have a screw that has a handle of radius 20 centimeters and a pitch of 0.5 centimeters. What is the velocity ratio? So the velocity ratio, as known, is 2 pi r divided by pitch. So when you have 2 pi multiplied by radius of 20, that gives us 40 pi divided by 0.5. Invariably, we have 80 pi. And that gives us an approximated velocity ratio of 251.2. The velocity ratio is 251.2. So a screw provides a large mechanical advantage. A screw provides a large mechanical advantage, allowing a relatively small turning force to produce a much larger force. So that the key point in screw is that it provides a larger mechanical advantage, allowing a relatively large turning force to produce a much larger force. So towards our conclusion, I want to thank the management of this FM station, O2 FM 96.9, situated at the Knowledge Hub, 121, 123 Obafemi Awolowo Way, Okeado, Ibadan. So I want to thank thank my production engineer. I want to thank my producer, Mr. Femi Ogunyejo, and the head of station, Mrs. TOKUNBO-ISHOLA, for the time made available to me. The useful time, for example, most importantly, and for making today a reality and a useful time spent. So wherever we are today, let's observe our surroundings. Let's watch vehicles. Let's watch people walking. Children play adequately and reasonably. Play football. Watch birds flying and even someone pushing a wheelbarrow. You will discover that physics is every day and everywhere. So I remain your host, Kenny Badmus. Keep listening to School on Air Physics on Oxygen FM 96.9, the station that informs, the station that inspires, and the station that ignites. Until next time, stay curious, stay focused, and keep discovering wonders of physics. Goodbye. See you once again. Thank you. God bless.
Can you handle this? 1, 2.